Greetings everyone. I will now introduce you to a concrete implementation of the mass debugging framework. First, let's examine the design language SAML. As you see, SAML has multiple viewpoints from which you can model different aspects of multi-agent system. As I said, first we start with the general mass viewpoint, where we can define agents, environments, and capabilities. All the work can be done with drag and drop from the palette on here. As you see, I can already I already modeled some example, but beside that I want to show you capability of the tool, so it's easily drag and drop on from palette to viewpoint. It creates, as you see, an agent here, or a capability, or an environment, and also there's some edges. It means that I can easily connect these elements together with each other using these edges. For example, if an agent, implementing sub capabilities, easily I can do it with this edge. So I want to delete these ones. As I said, all the work can be done with drag and drop from palette on the right side. If we double click on any item on this viewpoint, if there's a viewpoint associated with that item, it will open the viewpoint. For example, let a look inside the serving drinks capability. As you can see, beliefs, plans, and if available sub capabilities can be defined here. Again, using with palette on the right side, easily drag and drop mechanism. You can use easily drag and drop mechanism on here. In this example, here we have two plans are defined that can be related to owners want during event, and also one of them, this one has a precondition, or we can say that context of the plan. What is that? So this plan can be executed if agent believe that drink is available. So the second one is there's no precondition. Again, if we double click on any plans on here, we can enter the details of the plan. Here we can see details of the plan. The first action, release available drink from the agent's mind. This is the delete belief edges, and the final action, the last action, sends a message. This is the message action. Special action sends a message to owner agent, and this message has a belief. It means that actually it is the context of this message. It means that this belief will be added on the target agent, and also this message cause and something on the environment. How can we understand that? Because this message is linked with an operation on the environment, and it means that something will be happen at an environment when agents execute this action. So if We return to multi-agent system diagram again. Finally, we can examine the environment, inner side of the environment element. When we click on it, double click on it, we can see the environment on here. As you can see, there is events and operations, which it's very easy and non-complex modeling area or viewpoint. There is some operations and events, and there is a one link between them, which is post event link. This diagram explain us all of these three operation will cause these events on the environment if an agent execute an action on the client side which is linked on these operations. So that's the SAML model. We are actually it's the implementation of concrete implementation of design language, which is introduced in the framework. When we done it, when we create design side, when we done the design side of the system, and it means that when we are done designing a mass, we should we need to convert the SAML instance into a mass runtime language instance, or mass-RL instance. Actually, mass-RL is an implementation of the concrete implementation of the runtime language in the framework. Here we use ATL transformation. As you can see, there is an ATL transformation named SAML to mass-RL. It's easy. You can just give the source model in here. You can choose from workspace also, and you should give the target area or target model. That's all. It's enough. It will be enough to give source model and where you want the target model to occur, and press run button. It will convert your source model to target model. So we have actually converted one here. Sorry, this one. As you can see, it's the our runtime language is created from design language, and we will use this language to the debugging system. But before the debugging system, we should it's not necessary, but without this we cannot control this these things with breakpoints or other stuff. So if we don't link this one with a simulation environment, it's just a basic simulator. We cannot use a debugging operation or some other capabilities on this tool. So we want to link and has a simulation environment with this mass-RL before use it, but it means that we should model the environment to start debugging, and this is the mass-ML example, and I want to open it and introduce you to something on here. In this simulation environment, also you should know that our simulation environment, or otherwise mass-ML language, is again concrete implementation of the environment modeling language in our framework. There is two different kind of breakpoint in here. One is time based, other one state based, and other one is condition based. I will introduce each of them. Time based one is very easy, very understandable or comprehensible, which is actually breakpoint will triggered when the correct time is come, which mean that actually what is the correct time is tick count in the simulation environment, because our simulation is use our simulation environment uses discrete event mechanism. So it uses tickets, actually not the exact time, not the real time. So for example, this one time based breakpoint will be triggered when the system comes to or will come to 6th state. The other one is condition based one. Again, it's very simple. Condition based one has a qualifier, which is an element from a runtime language or runtime instances. In here, in this example, we choose message named order. When this message, actually, you know that it's a kind of action. When this message activated or used by an agent, again this breakpoint holds the execution of the simulation. This is the second one, and third one is state based, maybe as the complex breakpoint, or more complex than others. In here, we should, first of all, to use state based, we should define a pattern in the for this runtime language. To define it, we should create another material which refers to some kind of subgraph of the original or the system's material. I want to show it you how we can do it. We can directly create material without using an modeling environment, because material, as I showed you, there is no palette or right side on the material, because in the material side normally we don't need to create anything on this side, but to use this pattern mechanism, we should create that, as I said, a subgraph of the original one. So one way using directly or creating something directly from this explorer with for example, click on it and edit something, or directly edit it open with text editor or system editor is better to edit or something, edit or delete it or update something on it. Another way to use it, creating small SAML to reverse it and convert it to material to use it. For example, in here we have the very small SAML, which is one environment, one serving strings, and one robot. Also, this in the serving strings there's two plan. Both of them handle this event, etc. So when we finished creating this small SAML, again we can transform it to or convert it to material, and as you see, there is a little small material, and from this material, if you want to specific condition, you can change on it. For example, in here we can see that we are trying to find a pattern which has two plan. One is active and one is on the queue of the robot agent. As you can see on here, plan is in queue. This one also, when you click on this plan, as you can see, it's activated, and this plan give the rank owner plan has this tree, has this tree action. Also this plan and both of them should handle this event in this environment. So when our execution, simulation execution, faces this kind of subgraph or uh, subsystem on the whole system, it will pause the execution, and also this the third uh, version of the breakpoint. Beside breakpoint in our simulation environment, we can create some scenarios. For example, in here we can create scenario one. For example, for being example actually, there is two kind of different nodes on a scenario diagram or scenario viewpoint. One is occurrence, other one is fiction. Basically, occurrence is a kind of thing that if you want and something occurs in a system within a special ticking or special time on the system. For example, in this element in this occurrence, we define that event owners want drink events will be occur the exactly initial time of the simulation. How we can understand that? Because we set the when 0. If you, for example, if you set it to 10, it means that 10th cycle of the execution of the simulation execution, again this event will be activated. So by this way you can define different time-based things you want. If you want to occur something on time-based, you can use occurrence. And other thing is fiction. Normally in the default mechanism of the our simulation environment, all actions return true. It means that agent can do this action without face any difficulties. It's the default behavior of our simulation environment. But if you change it, if you want to change it, for example, you want to this returning true mechanism under link with a condition. In this, for example, in this example, you should use fiction element. When you create fiction element, it comes here with a condition actually. For example, in here we create a fiction linked to, and this fiction linked to one action named or called go to owner, and also return is true. It means that if this condition is true, this action will return true. But other side, otherwise, if this condition will not hold, this action should return false. Again, if you click on this return one time and it swap to false, it means that if this condition holds, this action should return false. Okay, I want to close all this stuff and I want to return my runtime diagram, and here as I said before the start, we should give the reference of a simulation environment which we want to use. Click on this three dot icon and select our simulation environment on here and finish. Now this simulation environment linked with this runtime diagram, so we can start it, you can use it now. So I want to show you our debugger operation, which is resume, stop, step into and step out as we described. When you click resume, it continues until some breakpoint will will activate will be activated and stop and pause our execution. When we click step into it, it acts like normal debugger on the program side, programming language side. So it dives into the detail of this detail level or current detail level. It means that, for example, down to the plan detail, something like that. Or if you step out, again, it's the similar step out in the programming language. It means that just past, for example, just past next plan, not dive into the detail of the plan. It means that not dive into step by step execution of the actions, just past the next plan or next this plan level action, not the detail of the executing plans. So if I click on resume, it will go to find an exec to crash and activated a breakpoint. I want to show you this one. I click on resume, and as you can see, system will pause on this stage. But it's easily understand that we faced with state based breakpoint activation, because I can understand from this example this plan active, this plan in queue. So also we have robot on here. Both of these plan handle this event also, and this plan has these three actions. So our subgraph, actually we catch we can catch our subgraph in the state-based breakpoint. So system is stop. Again we can resume it, or from now on we want to step into use. We want to use step into debugging operation. When I click one time, as you can see, it step one cycle, and we can see the just after the situation one tick is executed. So it means that simulation execute on cycle one time, and we reach to this state. But if we use step out means that execute all things, all action on this plan, and go out to this plan, and this the step out. So if we again one time step into, from now this plan is activated, and order also if we click the resume, if we click the resume in the first time we occur a breakpoint, now against it should again their simulation environment should be paused again. Why? Because we faced with another breakpoint, which is order message or order action is activated. So that's the general use of our tool. So by this way you can debugging anything. If you want that, you can add some breakpoints. You can execute or you can execute your system on the model level and try to understand problem and failure of your model on the modeling level without transforming code or don't without making any effort to creating a whole program or whole project. So that's all actually. Thank you for your listening. If you have any kind of question about our tool, do not suffer to email us.